Now we will jump into the code and we will see the code one by one. First I will open my notepad++. I will go to open folder. Project is already with me. So this is the project. If you will see our software architecture, we should start from the bottom. So at the very bottom we have the driver. So in the driver first file we have the register address map. So this is the RCC base registers and this is the port A base register. This RCC base register, if you remember, check this in the datasheet. So here if you will see in the datasheet, this is the RCC register and this is the starting address of the register. So that's why this is the base register. In the RCC registers, we have many set of registers and all those registers we access using the offset from this base address. All the different register offsets I have kept it here. You can go through the document and you can check. For example, RCC CR offset, RCC control register offset. If you will go to the user manual, the RCC register and RCC clock control register, RCC CR, then you will see the offset value is 00, and the same you can see in my code also. After that I have created the register variables with the offset plus base address, and these are volatile types because we are accessing the register. Similar to this, we have the GPIO port registers. For every GPIO we have different registers, and all the sub registers offset are same. So that's why I have created just common offset for all the registers. Like our LED is connected to port A, that's why I am only taking the currently port A base address. So this is the port A base address 400200. If you can verify this by going back to the data sheet and you can see GPIO A registers. This is the base address of this register. Same we have used in our code. Now different sub registers we have here for GPIO A, and these registers we will be using, not all, mostly one or two. So this is the very first file, which is address mapping file. Now after that system clock configuration comes. Here we have done the system clock configuration exactly using the same registers what we defined into the address mapping. So first I am choosing the HSI, means internal clock. This registers 0th bit I am setting 1. Why I am doing this? If you will go into the user manual, then you will come to this RCC CR, RCC control register, and you will scroll down. Then you will see we have bit 0, and what bit 0 says is, if it is 0, HSI oscillator is off. If it is 1, HSI oscillator is on, means internal clock is on. So that's why we are making the bit 0 as 1, because we want to use the internal clock. And after that what I am doing is waiting for HSI to be ready. I am checking whether the RCC CR register first bit is 1 or not. If it is 1, it means it is ready. I got to know this from user manual. So if you will see bit 1, so if it is 0 means oscillator is not ready. If it is 1 means oscillator is ready. Now after that I am setting the prescale for AHP. So currently internal oscillator is 8 MHz. I have not done any PLL configuration. It means my system clock is 8 MHz only. And after that I am setting my AHP prescaler RCC CFGR. So 6th bit I am making it 0. So if you will come here, so this is the RCC clock configuration register. If you will go inside this and if you will see what 6th bit is about, you scroll down, you will see bit 4 to 7 is AHP prescaler. This AHP prescaler is from the system clock, how much clock frequency I want for the AHP. So defaults are 1 and I have made this one 0. It means I am dividing it by 128. 8 MHz divided by 128 is the clock frequency of my AHP. So now we have to select the oscillator, like which oscillator I want as a system clock. So for the oscillator 0th bit and the first bit I am making as 0. So let's see this also. Both I have made 0. Both 0 means HSI oscillator selected as system clock. So here we have to enable the HSI. So this description is not 100% correct. So I am enabling the HSI here, and here I am selecting the HSI as my system clock. Now this is perfect. Now check if selected system clock is correct. Here we are checking if the system clock is correct or not, and we are ending this status register with bit second and third. You will see the bit second and third. It means the HSI, if both are 00 means HSI used as a system clock and it is ready. So this was all about the system clock configuration. Now apart from this, we have the port .h. In the port, we have to configure the clock for port A. It means we have to configure the clock for HP1 clock configuration. Then port configuration we need to do, and then the toggle pin. So first is the port clock configuration. How we will turn on the port A clock? We know that port A is connected with the HP1. So we need to tweak the RCC HP1 register. And what we are doing here is 0th bit we are setting 1. You will scroll down all the way, then you will see here that IO port A clock enable. If you will make it 0, port A clock disable. If you will make it 1, port A clock enable. So that's what we have done here. We have enabled the port A clock. Why? By making bit 0, 1. Now you know our DIO pin we can configure as an input also, and we can configure as an output also. So currently we are doing the LED blink program. So for LED we need to configure our DIO pin as output. So that is nothing but mode. We are setting the mode as output mode. What we have done is we have set the pin 6 mode output, for which GPIO mode register 12th and 13th with 12th we are setting as 1 and 13th we are setting as 0. So if you will go to the document, so this is the GPIO mode register. Here for all the ports same mode register is there. So let's imagine this is for port A, and in the port A we have different pins. This mode register is for pin 0, 0, and our LED is connected at PS6. So this is 0, 1, 2, 3, 4, 5, 6. So this one. These are the 2 bits which we have to change. This is the 12th and this is 13th. And if you want to make it as a general purpose output mode, what you have to set is 0 and 1. Means 13th should be 0 and 12th should be 1. So that's what we have done here in the code. After that we are doing a toggle pin function. When you set the pin as a output, so using which register you will make it high and low. So using ODR, output data register. So if you will go to the GPIO ODR register, output data register. So this is output data register of our pin PS6. If you will write 1, pin will become high. If you will write 0, pin will go low. That's what we have done here. If you will see. Now we see the driver part. On top of driver, BSP should come, but since we are not using the BSP to keep the project simple, so on top of BSP board support package, our application comes. So let's see the application part. So in the application part, I have just created one simple delay function. We are not using any timer. It is just a for loop which is running 1000 times. Just some random delay. We have our main function. Before using the port, first we need to configure the port. So we are configuring the port as mode output. After that, we are accessing the port driver and we are calling this port config. And after that, I have just given one endless while one loop. And in the while one loop, I have called the toggle pin from the driver only. So this toggle pin, it will relatively make the pin high low, and this delay function I am calling and giving the 1000. So it will create some delay. So this is my application, simple. We saw the driver part, we saw the application part.